this recording tomorrow on Canvas for students who couldn't make it tonight or who can't stay for the whole session. Okay, all right, so the first topic on here is evaluating a factorial. Now, you should have learned by now how to use your calculator, and some of your calculators might have a PRB or probability menu that you can access, and you can find the factorial, you can find NCR, you can find NPR. Other calculators have these functions directly somewhere on the face of the calculator. So be really comfortable with accessing these functions before you go into this test. Now, if you try to type 526 factorial divided by 523 factorial, you will get an overflow error. And this is because these values are so large. A factorial is the product starting with that number, counting down all the way down to 1 with all of the previous values. So it's a huge product, and most calculators can't perform that unless you have maybe a graphing calculator or a computer. So we have to expand this by hand. And that would be a really large expansion, except we do have a division, and we do have 523 factorial, which is 523 multiplied by 522, 521, all the way down to 1. So it's all those factors. So if I just start counting down, 526 times 525 times 524 times 523, and then I put the factorial, that represents all the previous numbers down to 1 that I'm not going to write, and I can cancel those factors very easily right there. So then I just have to find the product of 526 times 525 times 524, and your calculator can compute that, 144,702,600. So overflow error means you've got to expand it by hand. You will have something like this on the test to demonstrate that you do understand the math behind expanding a factorial. Any questions about that? Okay, now the next question is the difference between a permutation and a combination. Now notice this instructions say rewrite them using factorial notation, and then you can use a calculator to evaluate. So you do have to know two formulas on the test. NPR is n factorial divided by n minus r factorial. And then NCR is n factorial divided by n minus r factorial times an extra r factorial on the bottom. So you do have to know both of those formulas and then set up the formula with your problem. So 10 permutation 4 is 10 factorial divided by 10 minus 4 factorial, or 10 factorial divided by 6 factorial. And then from there you can, work it out like I did up in the previous problem where you count down from 10 until you get to 6, or you can just type 10 NPR 4 using the NPR function in your calculator to solve this. But just note that on your test, having the answer doesn't give you full credit. You have to show the formula here. And then for the combination 20, combination 15 would be 20 factorial divided by 20 minus 15 factorial, and then the extra 15 factorial. And then you can simplify that to 20 factorial divided by 5 factorial and 15 factorial. Now note, if you're trying to type this particular expression in your calculators, whenever you have multiple factorials on the denominator, you do have to enclose that in parentheses. So you would have to do 20 factorial divided by parentheses 5 factorial times 15 factorial to get the calculator to solve the denominator first before you divide. So that's a little calculator tip there. And this answer is 15,504. Okay, so make sure you know these two definitions, NPR and NCR formula, and set it up, and then you can get the solution. Okay, That is the only place on the test where you're going to be required to show those formulas. So for the rest of the problems, if you do have a permutation or combination, you can just type that in the calculator and you don't have to show the work. Okay, so question 3. Find the number of different ways that a committee of 10 can be selected from a club of 30 members. So this is just a counting question, and notice that we have two values, 10 and 30. In these problems, the larger number will always be n and the smaller number will always be 30. Next question. Are we placing these committee members into positions? Or if we're not, then order doesn't matter. We're always going to associate positions with the permutation. So P in position is P permutation. No order, that means it's a combination. And this doesn't indicate that we're placing them in positions. We're just picking them on a committee of 10. So I'm going to choose NCR 30C10. So the bigger number always goes on the left. And I'm not going to write out the formula. I'm just going to use the NCR function on my calculator. So if you do have questions about how to type that in without having to work out that long formula, let me know, because you'll need to be able to use that for your test. So you don't assume that you're putting them on positions. It just says you're picking people in a group. Basically, you're putting them on a group of 10 together. It doesn't indicate positions. There was a previous question that was asked where it did say applicants were applying for positions. And so in that particular case, since they are in positions, then it would be a permutation. Yeah, but if you're just selecting a group of 10 people, then it doesn't matter what order they're in. They can all be on that committee together. Names in order doesn't matter. And then question 4 is a really good comparison. Find the number of different ways that 3 people can be picked for president and vice president and secretary out of 30 committee members. So here again, we have the larger number is N, so we have 30 for N. The smaller number will be the R. And because we are putting people in positions, if I'm picking John, Mary, and Elizabeth, and I'm just putting them on a committee, then the order of their names won't matter. But if John gets the position of president, Mary is vice president, and Elizabeth is secretary, then if I switch that around, that's an entirely different setup. So if Mary was president, that's a different type of committee. So because we're placing in positions, it's a permutation, and this would be 30p3. Again, you can use the formula up above, the n factorial divided by n minus r factorial, or just use NPR function in your calculator, 24,360. So many of these questions, there's not a lot of work that you would show, but definitely don't just show your final answer, because I need to see what you're typing in the calculator. So at least at the minimum, write out the 30C10. Okay, and then number 5 is a really specific type of a question that we've also learned. It's a password question. So any type of a code or password, or even like the phone number and zip code questions, where you have specific things that go in each position of your code, I think the best strategy is to use blanks. Okay, so any type of password, zip code, phone number, use blanks to represent each value. So our password has to have 3 letters followed by 2 numbers followed by 1 character. Now, we have 2 choices for that character, but we have to pick one. So the total blanks are 3, 4, 5, and 6. So I set up my password. Now the first 3 positions have to be letters, and then I have 2 numbers, and then I have a character, and I have a couple of choices. Now in each blank, put your total to choose. So every time we're talking about letters in the alphabet, there are always going to be 26 letters. So I start with 26 letters, and then I got to check the problem to see if I'm allowed to use the same letter again or if I cannot repeat it. Now this says that it's repetition of numbers and letters is allowed. So in all of these, I have 26 choices for the letters. Numbers are the digits 0 through 9. So just look at your calculator and you'll see that there's 10 total digits to pick. And then the characters, we could pick one of these two symbols, so there's two choices. And then we use the fundamental counting principle that says you multiply the number of ways to pick each event. And to simplify this, you could also use exponents. You could do 26 to the third power times 10 to the second power times 2. And that's going to give you 3,515,200 passwords that are available. So any questions? I've finished the first page. Let me zoom out. Anybody attending tonight, if you've got a question, you can unmute yourself or just use the chat and I'll respond to that. Okay, so the next page, the first question at the top of it, let's look at the strategy we can use here. So we have out of 315 houses that Habitat for Humanity built in New Orleans after Hurricane Katrina, 70 have tested positive for corrosion problems caused by defective Chinese drywall. If 3 houses are randomly selected, find the probability that 2 test positive for corrosion. So I'm seeing this mentioned again, so that's a trigger there that you've got to match something up, because we talked about positive for corrosion up here and we had a different total for that. And then 1 does not. Okay, so we want to pick 3 altogether, splitting it up, 2 with corrosion, 1 with not. When we have different totals, we need to set up a combination for each. So the 2 categories here, like sometimes these questions, the categories are genders, like males and females, or maybe it's different types of books that you're picking. In this example, the categories are houses that are positive for corrosion and houses that are negative for corrosion. So I'm going to put positive combination and negative. And so if you had gender, you would do a combination for the males and a combination for the females. Now we start by locating the N and the R for the positive. So the bigger number, notice that we've got a big number here, 315 houses. That's combined. So I need to parse this out into the different categories. So if you keep reading, there are 70 total positive for corrosion, so that's my N. And then we're picking 2, so that's my R, 70 picking 2. And then for the other combination, the negative, I know I'm picking 1, so that's my R, but I need to know the total. And this is where the 315 comes in. There's 315 total, minus 70 that are positive, and so your missing total is just the difference there, 245. That must have been negative. So that's my N, 245. If you add up the left side numbers, that should total up to 315 combined. And if you add up the right side numbers, 2 and 1, is the total 3 houses that we want to pick all together. So let's multiply this together, because we're always using that fundamental counting principle that says you multiply the number of ways to pick each. And this is where I don't want to use the formula and show the work. I'm just going to type this directly in my calculator. So 70C2 is 2,415 ways. 245C1 is 245. Find that product, and this will give you the number of ways that you can pick that specific combination of houses. So this equals a product of 591,675 ways. Okay, so normally we would stop there. That's the number of ways we can pick these houses. But notice that the problem says, find the probability. When you see the word probability, you have to create a fraction. Probability is always dividing by total sample space. So I have an extra step where I have to divide by one more combination. And this is the combination where we have 315 total houses picking 3. It's always a combination here because the order of the houses that we pick does not matter. They're not in specific positions. Notice that the denominator is one combination. It comes from kind of joining these together, and you add up the left side numbers to get 315. You add up the right side numbers to get 3. So 591,675, and that will be divided by, I think I've got, yeah, 5159805. There's all the digits there. So 5,159,805. Divide those. It says express the answer as a decimal to 3 places. So 0.115 would be the final result. And that's 11.5% probability if you turn that into a percent. Okay, so different totals. If it's talking about different categories and you're picking some of each, do a combination for each, just like I've split it up here. And sometimes you're missing one of the totals, and so look for that overall value that you can subtract to find it. Okay, so any questions on that? Okay. All right, so moving on, now we're going to get into some other kinds of basic probability questions. In example 7, we have a marble that is taken at random from a box containing 10 marbles numbered 1 through 10. Find the probability of getting a number less than 10 and express the answer as a simplified fraction. So please read the instructions on your test because it will tell you how to do your answers. So probability means I need to make a fraction, and on the top is the number of ways to get less than 10, so it's that specific event. And on the bottom is total events, and we could divide those. So in this situation, we have 10 marbles numbered 1 through 10. Less than 10 would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 9 choices out of 10 total, and then 9/10 is already simplified. Now, find the odds in favor of getting a number greater than 8. Odds is very different from probability. Probability is a fraction, part to total. Odds, I like to represent it with a colon, and it's part to other part. The total is never in the odds, but the two parts should add up to the total. So notice how I'm not going to write this as a fraction. I'm going to write it as a colon, part to other part. First, odds in favor of selecting a number greater than 8 means I want to put greater than 8 first, and then remaining choices on the other side. So in my marbles, greater than 8 would be the numbers 9 and 10. So I have 2 choices. And so if there's 10 total marbles, 10 take away 2 gives me 8 remaining choices. So 2 to 8 would be the odds in favor. Notice that 2 plus 8 equals 10, but you don't put 10 in the odds. Now this simplifies just like you simplify fractions. 2/8 simplifies to 1/4. So this would simplify to the odds 1 to 4. So very big difference in how you write the answer. Probability can be a fraction and odds is part to part. Question C says, find the probability of getting a marble that is either less than 4 or even. Okay, so less than 4, if we just look at those specific events, would be 1 and 2 and 3. Or it could be even. So out of all the marbles, the even numbers would be 2, 4, 6, 8, and 10. So here's my evens. Here's my less than 4. So when we set this up, if it says or, there's a probability of A or B rule. Or is always add. Probability of A or B is the probability of event A plus the probability of event B minus the probability of A and B overlapping. If you look at these events that I wrote out, I do have the number 2 in both of these totals. So if I total up, how many ways can I get a number less than 4? There are 3 ways out of 10 total. How many ways can I get an even number? 5 ways out of 10 total. But I counted the number 2 in both of these. So I have to subtract one value that was counted twice. So 3 plus 5 is 8. 8 minus 1 is 7 out of 10. And notice the denominator is 10 because that's the total marbles that we have to pick from. So every time we see the word or, we want to write out the or rule and then plug in your totals that go with that. Any questions on that second page? I'll zoom out again and just show what we did. We did 6 and 7 there, and looking at the difference between probability and odds. Let me know if you need clarification there. Okay. And then I had a question going back to the password question. So the question was, in questions that have letters and passwords, do you have to include capital letters along with lowercase letters, which would, you know, if you said that there was a difference, which when we pick passwords for like your email password, many times uppercase and lowercase are counted as different letters. So that would be 26 capital letters and 26 lowercase letters, which would give you a total of 52 letters. In these password questions, if they don't indicate that capital letters and lowercase letters are counted separately, then it would just be 26 letters, not choosing capital or lowercase. So it's more common here to just see when they say letters, you just assume 26. Okay. Good questions. Thank you. Okay, so I'm going to go on to the next page and let's look at the question up above. A jar has 7 red and 6 green, 8 blue, and 4 yellow marbles. Okay, so if we total up, just to find our total right here, we're going to get 25 marbles. A marble is chosen at random, and then a second marble is chosen without replacing. So let's find these probabilities as a decimal to 3 places. So what's the probability of selecting 2 yellows? So notice that we are picking 2 marbles, but we're not reaching in and grabbing both at the same time. We're picking one, looking at its color. We're not replacing it. We're picking a second marble and noting its color. So there are 2 selections separately that we need to account for. So always note your total, and then you need to do a fraction for each selection. So I have the first marble, the second marble. I want it to be yellow. Okay, so there are 4 yellow chances, and there are 25 total marbles. So my chance of getting a yellow are 4 out of 25 the first time. If I don't replace it, when I pick again, then I have now changed my totals. I only have 3 remaining yellow, and I have 24 total marbles left in the bag. So in these consecutive events, if you don't put it back, you have to change the totals for each selection. Now this is called a consecutive event, picking more than one. And this is using the AND rule. So whenever you see consecutive events picking more than one, it's probability of A and B happening. And the rule for this is we do the probability of A multiplied by the probability of B, given that A has happened. So this means change totals if you're not replacing. So with these consecutive events, we multiply. So I want to multiply this together and just compare this, guys, to the one we just did where we did the OR event. With the OR event, we add our totals together. So OR is add, AND is multiply. So I'm going to do 4 divided by 25 times 3 divided by 24 equals. I'm going to type it in my calculator using the division button, not the fraction key, because this is going to give me the decimal right away, 0.02. And it said to round it to 3 places, but the third position would be a 0, so you can cut it off there. Okay, so what is the probability now of selecting a red and then a yellow? So probability of red and then yellow. So red the first time and yellow the second. So order definitely matters here. So I'm going to have a fraction for each of these that I'm picking. Oh, got to catch up here. Something's slowing down. So the red total is 7 total reds. If this isn't going to, let me go ahead and close this down if this is not going to work. Yeah. Give me just 1 second. I'll close that down and reopen it. Try to share that again. Okay, so hopefully you guys can see that again. Let's see if this will work now. Oh, well, maybe not. Let's see. Sometimes technology is just so great. Try it again. Okay, yep, it's just going out on me. Okay, so let me try with this mouse then, because the pen is not working for some reason. Okay, so the red totals were 7 total red. Okay, so I've got 7 red out of 25 total marbles. And then we have our yellow. So when we pick our yellow, we've got 4 total. Now this is a different color, so I'm holding out that first marble, and now I want to look at my chances of getting yellow. So I've got 4 total yellow since it's a different color, but my total marbles has gone down to 24. I'm writing the best I can because the pen went out there. And you do multiply because this is a consecutive event again. So 7 divided by 25 times 4 divided by 24, 0.047 would be the decimal if you round that to 3 places. Okay, so any questions on those two? I'll try one more thing here, try to unplug and plug back in. If that helps. Okay, so no questions yet. Okay, so let's keep moving on. Question 9 talks about probability involving a deck of cards. So be familiar with a deck of cards. A deck of cards will always have 52 total, 4 suits. So you've got red suits are your hearts and diamonds. Black suits are clubs and spades. 52 divided by 4 gives you 13 cards in each suit. Your number cards are 2 up through 10, and then you've got your face cards, Jack and King and Queen, and then ace is just ace in these probability questions. So when it says, what's the probability that 2 kings are drawn? I still don't think this is going to work. We are picking a single card without replacement, and then we pick a second card. So we will have to do a probability for each selection. So a fraction for the first, a fraction for the second. Now in a deck of cards, when you're talking about an individual card type, there's always 4 of them. So you can get the king of hearts, the king of diamonds, king of spades, king of clubs. So there's 4 chances of getting a king out of 52 cards. Now, if I want to get a king again and I'm holding out that first card, there are now 3 kings out of 51 cards. Multiply that together and it says do a decimal to 3 places. So we have 4 divided by 52 times 3 divided by 51.005, a really small chance there. Okay, and then we have, what's the chance of getting a heart first and then a diamond? So these are entire suits of cards. So there's 13 total hearts out of 52 cards for the first selection. And then for the diamonds, that's a different suit. So you haven't changed that total. There's 13 diamonds when we pick, but we have 51 total cards. So that remainder has to go down on the bottom. So 13 divided by 52 times 13 divided by 51.064 would be that probability for that event. Oh, and then odds, I like those too. So before we go on, these 8 and 9 are really similar types of questions. It's just different scenarios, deck of cards and marbles. All of these were involving consecutive events. So remember your 2 different probability rules. Or is adding. When you're picking more than one item, do a fraction for each item and do the and rule where you multiply your probabilities together. Okay, if the odds in favor of an event occurring are 32 to 35, yep, this is still not going to work, then let's find the odds against. Okay, so notice how they wrote the word 2. You can also write that as 32 colon 35. It means the same thing. And 32 and 35 don't simplify or reduce. So if this is the odds in favor, then our total events, if we add 32 plus 35, that will give us 67 total events. So 32 in favor, 35 against is the way this is set up. So to get the odds against, all we do is switch the numbers, 35 to 32. So don't make up new numbers or anything. It's just taking these numbers and switching the order. But when we want to do the probability, then we do have to set up a fraction now. So what are our chances that the event will occur? Well, that's the odds in favor. So we're going to put 32 on the top. And then the denominator has to be the total events, which is 67. So when you switch from odds to probability, you do have to add the 2 parts together to get the denominator. And always try to reduce your fractions. You can use your fraction key on your calculator to assist you. This doesn't simplify. So I apologize for the writing. It's the tablet is not working. I'll just do the best I can. Let me know if you need any clarification there. Okay, so question 11, you've got like different parts to this, and then question 12, again, different parts. These are very similar to each other. They're just giving you more practice. So I'm going to pick question 11, and I'm not going to do 12. But if you do have a question, let me know tonight. Either unmute yourself or use the chat. I'll pull that chat back up so I can see that. Okay. A question before I start this related to my math lab, and there were some questions about the roulette wheel. I don't put that type of question on the test. If I did, I would tell you about the different totals because that's not a common knowledge type of a question. So no, you do not need to memorize the properties of the roulette wheel for the purposes of your test. Just for the My Math Lab questions, you can, Google that or use the question help videos that they provide for you to help you understand that. You do need to know the deck of cards though, so that was a good question. All right, so in this table, we're asking different college students about their preferred type of pizza. Okay, so the table is showing, let me go back up. We have freshmen and sophomores, juniors, and seniors. Now, sometimes when we have tables, they do total up for you, the rows on the columns, but sometimes they do not. So be really careful, like when you're adding the numbers, don't add the totals again into that. And then we have cheese, meat, veggie, and again, we've got this total of the columns and the rows. If one of the students is chosen at random, let's find the probability that the student was a senior, given that the preferred pizza was veggie. Now, this is a special type of a probability question. When it says given that, that is a condition. So I like to focus on given that, and I like to circle it or box it in, and we're placing a condition on our sample space. So when you see given that, you should ask the question, given that what? Well, it comes after the phrase, given that the preferred pizza was veggie. So what you want to do now is restrict your whole table to just the veggie, and the veggie is a row. So I'm going to highlight the veggie row, and I'm not looking at any of the other numbers. So now that I've restricted my table to the veggie row, let's set up the probability, and the probability does go left to right. So like what's mentioned first, when you set up your fraction, the first thing goes on the top. So the student was a senior. So in the veggie row, seniors are 25. So that goes on top. Given that the preferred pizza was veggie, so the denominator is the total of your row or column. In this case, it's the total of the veggies, which is 78. So with given that, you're placing a condition and you're restricting your table to either a row or column. 25 over 78, the decimal is 0.321 because it said to do a decimal to 3 places there. Okay, so I'm going to undo all of that and let's look at the next question. So the preferred pizza was cheese, given that the student was a junior. So again, we're placing a condition, given that what? Given that the student was a junior. So I need to restrict my table to the juniors, and the juniors is this column. So I'm not allowed to use any of the other values in the table, only looking at that column. So now we set up a probability fraction, and what comes first goes on top. Pizza was cheese. So in that column, cheese is 21. And then juniors is the denominator. So that's the total junior column, 59. And so 21 divided by 59, 0.356. I almost don't want to write those decimals because they're harder to do by hand with this mouse. Okay, so we've looked at two situations of given that's where you restrict, the first one restricted you to the row, the second one restricted us to a column. So if it doesn't say given that, then you use the whole table. So the next example says the student was a freshman or the preferred meat pizza. So this doesn't say given that, so we're using the whole table, but it does say or, and that is a rule. So that's probability of A or B. So remember that with the or events, we are supposed to add these together because it could be the first one or it could be the second one. always go to your table and kind of mark it because you want to see if the rows and columns intersect each other. So freshman comes first. So freshman was this first column, so I'm going to highlight that. And then preferred meat pizza. Meat pizza is this row. Now notice that my column and row intersected and the number 19 appeared in both of these totals. So I'm going to add, because it says or, first I do total freshmen, so I total up the whole column, 45 freshmen, plus the student preferred meat pizza, so total up the meat pizza row, 72. Now these do have denominators. The common denominator for these is going to be the total of all the numbers, which is 213. So there's 45 freshmen out of 213 people. There's 72 who preferred meat pizza out of 213. So it's the same common denominator because you're adding. Now I do have to subtract 19 because that intersected the row and column, and I counted it in both of these totals. So 45 plus 72 minus 19 gives you 98 out of 213. 98 divided by 213 is the decimal of 0.46 or 0.460 if you want to put the 0 as the third position. Okay, so every time we see or, we're using the probability of A or B rule, adding together and subtracting the overlap. Given that is a conditional probability, so if you see that phrase, you got to restrict your table. Okay, part D, what's the probability that the student preferred cheese or meat pizza? Notice we have that word or in there again, so it's adding. Cheese is first. So cheese is the row, cheese. And then meat pizza is second. So meat pizza is this row. Now notice these rows don't intersect each other. So the total cheese is 63. The total meat is 72. No values were counted twice there. So I'm just adding that together, 63 plus 72. Again, this is all out of 213, so you can even put it all in one fraction. Notice this is a plus, not a times. It's a little hard to write there. Minus 0. There's no numbers that were counted twice in this situation. So just 63 plus 72 is 135 out of 213. And so that is going to give us a decimal 0.634. Okay. So zoom back out there. So that table was used to solve for conditional probabilities, and then we had the situation of the OR events where you have to add the totals together and subtract the overlap. Any questions, or do I need to clarify anything on that page now that we've gotten through that? Okay. And again, I'm going to skip 12 because that's just more practice on the same kinds of concepts. Okay, so there's just one more concept that we need to look at for studying for the test, and that is the expected value question. So that's the very last lesson in chapter 11. Expected value questions are where we have a kind of like a game of chance, and we're trying to find out our overall expected winnings or expected loss depending on the outcomes there. So I'm going to go ahead and pick question 6. Nope, I think I'm on the wrong. There we go. Let's look at question 14. So this is on page 6 of your study guide. Actually, let me go ahead. I'm going to skip to, let's do 15. And then if we've got time, I'll go back to that one. There's a total of 4 different expected value questions that you can practice on the study guide. So question 15, tells us that we have a raffle ticket situation. So we have 15,000 total raffle tickets. Trying to use that, it's not working there. And we have different prizes. We have one first prize of $2,000, two second prizes of $750, and three third prizes, $300 each. If you purchased one ticket, what are your expected gross earnings? So first, when we set this up, the way I did it in the lesson is we set up a table, and we always want to look in these types of games of chance, wins and losses. It's easier to write the numbers for sure. So winning has to be a value. So always think about how much money do you win. So here we have a first prize, we can win $2,000. Now, you always have to take that total and subtract the cost to play the game. This one doesn't have a cost to play, so it's expected gross earnings, so it's not factoring the cost of the ticket. So we're just going to put the direct value, $2,000 here. We can also win $750. Now note there's two second prizes, but you only list the $750 once. And then we can win $300. Again, only once, so each unique value listed one time. Lose, there's no cost to play, so $0. Okay, now we set up our probabilities for each outcome. Now you need to look at the total tickets. This is going to be your denominator for each of these. So out of 15,000 tickets, how many tickets, 15,000, this is tormenting writing with a mouse, how many tickets win the $2,000 prize? And it says only one way to win. So you got one chance out of 15,000. Now you do have a better chance of getting the $750 prize. There's two tickets out of 15,000. This denominator does not change because it's always out of the total tickets. And then there are three third prizes, so you even have more chances to get the $300 prize, 3 out of 15,000. So if you count your wins up, there's 3, 4, 5, 6 ways to win. And so 15,000 minus 6 is 14,994 losing tickets out of, again, 15,000. So even though this expected value question doesn't have a cost to play, the loss is $0, we still set up the probabilities so that the sum of the probabilities is 1. 15,000 on top, 15,000 on the bottom. If you add the top, you get 15,000. Now we multiply straight across, multiply the value by its probability. So 2,000 times 1 divided by 15,000. The decimal is 0.133. 750 times 2 divided by 15,000. The decimal is 0.1. 300 times 3 divided by 15,000. The decimal is 0.06. So that's the 2,000, the 750, the 300, and then finally 0 times anything is 0. So we still have that there. Multiply across, add that column, and you're done. So this is 0.293. So we would report, because this is positive, this is a earning, it's a profit. So right now, without a cost to play, it's 29.3 cents per ticket is the gross earnings. So if there was a cost to play, like let's say the tickets were $3 each, then in the lose, you would not have 0, you would have a -3 because you're losing $3. And then you would have to change these values. So instead of 2,000, you would have 2,000 minus 3, which is 1,997. It's your net earnings. 750 minus 3 would be 747, and 300 minus 3 would be 297. So you'd have to adjust your earnings if there's a cost to play. But if I didn't change the chances, all these probabilities would still be set up with the same fractions. You would just be multiplying straight across, and you wouldn't have a zero. You would have -3 times 14,994 divided by 15,000. So it would alter, and it would probably end up being a loss for the person because you would get a negative result at the end. Okay. Any questions on setting up 15? I'm going to do 16 next because it's a good look at an application of these expected value questions with like insurance policies. That's a game of chance as well. Are you going to, pay the money out for a policy, and like what's the expected value for the company? They don't want to lose money on these policies. So a 60-year-old buys a $1,000 life insurance policy at a cost, so we do have a cost of $60, and this person has a probability of 0.972, so 97.2% chance of living. So they're probably going to live that year. Find the expectation of the policy for that year. So just like before, when I set up my expected value table, I'm thinking of win and lose. But in the context of this question, I need to think of it more as, is the person going to live or will they die? So you could think of that like a win and a loss. So these are the outcomes. Now I need to associate these outcomes with a value. So if the person lives, they bought this policy, they spent $60. So -60 is the value if they live. They lost 60 bucks. If the person dies, their beneficiaries get $1,000 minus the $60 that they paid that year for the policy. So every time there's a cost, you have to adjust your value by subtracting. So 1,000 minus 60 is $940. That would be the value if the person does not live. Now we set up the probabilities. Now with the raffle tickets, it's always going to be a fraction where you put the number of chances to win out of the total tickets. With this, the straightforward probability given is a decimal, 0.972. That's the probability of living, so make sure you match that up correctly with the living, 0.972. Now this mystery right here is found by remembering that the sum of all of your probabilities in these expected values must always be 1. Up above, I would have gotten 15,000 divided by 15,000. Here, since there's an unknown, we just subtract from 1 to find the missing piece. So 1 minus 0.972 is the opposite probability. This is the probability that they die. 0.028. So these two would add up to 1. So probabilities can be fractions or decimals or percents. Raffle tickets, fractions. If they give you a decimal probability, then you'll be working with decimals. Their sum is still 1. Multiply straight across. So -60 times 0.972 is equal to -58.32. And then 940 times 0.028 is 26.32. That's positive. And then you add together to find the expected value of the policy. So this is negative, and it equals -32. So the interpretation of this is that in the long run, it's a loss of $32 per policy for the person who purchases it. So it means that the company is coming out on top in the long run with all the people who buy this policy. Some will die, but most will live. So in the long run, they make money off of that policy. Okay, so good comparison of two different kinds of expected value questions. The previous page has additional practice. We've got like a minute left. I'll go ahead and set up 14 just to see, since it's got two different steps there. So Melinda buys one raffle ticket and there is one $1,000 prize, one $500 prize, and 5 $100 prizes. There's a total of 1,000 tickets, so that's your denominator for your probabilities, and there is a cost of $3 per ticket. So we always set up our expectation for one ticket. Even if it's talking about buying more than one, we always start with for one. So we can win the game or we can lose the game. And so the values of winning have to be adjusted. We have $1,000 take away 3 is $997. We have $500 take away 3 is $497. I'm cheating here looking at the answers so I don't have to do the math in my head. There we go, 497. And then we have the prize of $100. There's 5 of these prizes, but you only list it one time. 100 minus 3, $97. And then losing is -3. So always make sure your loss is negative. Now the probabilities are going to be fractions. The total tickets is always the same. It's out of 1,000 tickets. And there's one chance to win the $1,000 prize, so 1 out of 1,000. One chance to win the $500 prize, so 1 out of 1,000. And there's 5 chances to win the $97 or the $100 prize, so 5 out of 1,000. So right now, 5, 6, 7 tickets win. 1,000 minus 7 is 993 remaining tickets. So there's 993 losing tickets. And again, if you add all the top numbers, you should get 1,000 out of 1,000. Now we multiply straight across with each value and its probability, and you get decimals for each of these. So the decimals are 0.997, and then we have 497 times 1 divided by 1,000 is 0.497. And then we have 97 times 5 divided by 1,000, 0.485. And then lastly, -3 times 993 divided by 1,000, -2.979. Add all of those values together to get your overall expected value, and it's -1. So the expectation is a loss of $1 per ticket. So if she buys 2 tickets, it would be a loss of $2. So you can say -$2, or you can write that out as a loss of $2 for 2 tickets. So that finishes the topics that you need to know for the probability unit test. We've gone through pretty much every question on this study guide tonight. I'll post the recording of the study session tomorrow on Canvas. So before I close out the meeting, does anybody else have questions? I'm just going to check the chat. I'm going to catch up here. Is the test only over probability? That was a question. This unit was probability and counting. So there's lots of, I'll scroll back through. There's lots of probability questions. We had some probability rules like and or. We had odds. Odds is part of it. And then we had counting questions. That's your permutations and combinations. So that's the test right there. Counting and probability. If you're taking the test at an OTC testing center, are you allowed to bring water into the test? I'm not really sure what their policies are, so I would check the testing center webpage just to verify that. They also, if you Google OTC testing center, they have a phone number there that you can call and you can ask specific questions about that. And then on number 16, how did I find 0.028? So let me go back and respond to that question back here. So number 16 was the expected value for the life insurance. How did I get 0.028? Well, they gave me the probability that the person would live is 0.972. The opposite of living is dying. And the two probabilities, when you look at opposite probabilities, they have to add up to 1 or 100%. Kind of like, if I say there's a 60% chance that it's going to snow, then there would be a 40% chance that it wouldn't snow, and that adds up to 100% or 1. So 0.028 came from doing 1 minus 0.972, and that gave me the missing probability there. Okay, so I think I've responded to all of the chat questions. Thank you guys for joining tonight, and thank you for suffering through the horrible writing that I had to do with my mouse since my tablet just quit working, but I'm glad I was at least able to write and get that accomplished. So we got through it, and I will post that for you tomorrow. Again, I also will email the file that you can print to show your work if you're using ProctorU Auto. If you have any questions, let me know. Thank you guys for joining. I appreciate your attendance tonight and the great questions that you're asking. Thank you so much, guys. Have a good evening.